Tommy? Tommy? Kidding, that's our black hole that we have on our whiteboard. Because if I want to like write on the whiteboard while I'm projecting something, there's the glare from the thingamajig, and so that's I can't write. Like I have a huge scribbled out circle there, but you can't see it, and so we're just gonna deal with it, all right? I'm gonna go through some of the Jamboard problems from the Jamboard called Lewis Dot and Ionic Bonding Practice. This is the very first slide that has a practice problem on it. I'm going to talk you through it, and then we're going to go through, I think, 4 other ones. So this problem is asking you to draw the Lewis dot diagram to show the ionic bond that forms between lithium and fluorine in order to produce lithium fluoride. So here's how you kind of think about it. First, you pick out what are the atoms we're dealing with, what are the atoms that are going to be bonding. We are looking at lithium and fluorine. Step number 2, you go to the periodic table, you figure out what group each of those atoms is in order to figure out the number of valence electrons. So lithium is in group 1, which means it has 1 valence electron. Fluorine is in group 17, which means it has 17 valence electrons. Next, the thing that you need to think about is who is going to give up their electron and who's going to take them. So remember, metals are the ones that like to give up their electrons. Non-metals like to take those electrons. So lithium gives to fluorine. All right. If you wanted to be more specific, you could say lithium gives 1 valence electron to fluorine. But if you just leave it at lithium gives its valence electrons to fluorine, that's good. This is our dot diagram, and I know it's kind of difficult to see because we've got our massive black hole there and whatever else. But what you should see is that lithium, based on its number of valence electrons, the dot diagram just has 1. Fluorine has 1, 2, 3, 4, 5, 6, and then there's 7. I promise you, it's there. It should be on your screen. 2, 4, 5, 6. No, it's not. I messed up. I'll fix it in a little bit. You'll see it, a fixed version on your screen. But, so we're going to draw an arrow that shows from lithium going to fluorine. So that means that we have officially transferred electrons. What we end up with is lithium as a positive ion, a +1 simply because it lost only 1 electron, and then fluorine minus because it's gained only 1 electron, so it's become negatively charged by 1. That's our like brief example. Let's just get into the nitty-gritty of it. Let me jump ahead to another problem. Let me adjust my screen here. So we are going to do, can you guys see that all right? Maybe I'm just above the black hole. Perfect. Yeah, it's good. Okay, so in this one, this is on slide 4, we're looking at the ionic bond between calcium and oxygen in order to form calcium oxide. Remember, step 1 is to look at the atoms that you were dealing with. We have calcium and we have oxygen, so you'd want to write those in on your table as well. Go to the periodic table to figure out valence electrons. So calcium is in group 2, so it has 2 valence electrons. Oxygen is in group 16, so it has 6 valence electrons. Your next step is to figure out who's going to be giving and who's going to be taking. So we know that metals like to give, non-metals like to take. So because calcium is our metal, it only has 2, it's going to give. So calcium will give to oxygen. That's how I write it. It's short, sweet, makes sense to me. And then we want to actually draw that happening. So in here, this is where it's going to be like the biggest like time chunk of your assignment is just drawing the Lewis dot diagrams. We're going to start with calcium. It has 2 valence electrons, so our dot diagram looks something like that. Oxygen has 6. 1, 2, 3, 4, 5, and 6. So we want to show calcium giving its valence electrons to oxygen. So one of these valence electrons can be given to the side that is like open, right, that we need to fill with another electron, so that it looks like that. And then the other electron from calcium will go to the other opening. We just want to like double check ourselves here, right? We want to say, okay, did calcium officially give up all of its valence electrons, so now it has an octet? Yes. Does oxygen now officially have an octet based off of that transfer? 2, 4, 6, 8. Yes. So this is good. This confirms everything. Now the last thing we want to talk about is ions. So calcium, because it lost 2 valence electrons, it became more positively charged. So we put it in brackets, and because it's lost 2 electrons, it becomes more positive by 2, right? So see the +2 there? All right. Oxygen has gained some electrons, and so it's become more negative. How many times more? It's become more negative by 2, so it becomes -2. I hope you guys can see that all right. Let me know if you have any questions as this is going on. Okay, so that was on slide number 4. That is number 2. All right, I'm going to erase this, and let's move on to another one. I feel like Vanna White. Okay, next one is on slide... Slide 6. Let me get out of that black hole there. Oh no! Not like that. Oh no, not like that either. What a mess. Okay, we're gonna have to do the black hole in this one. This is slide 6, number 6. We're looking at the ionic bond between aluminum and chlorine in order to create aluminum chloride. So again, first thing is you say, what are the atoms and how many valence electrons do they have? So we've got aluminum and we've got chlorine. Aluminum is in group 13, so it's got 3 valence electrons. Chlorine is in group 17, so it's got 7. Then you have to think about it. Who is going to give up electrons? Who is going to take them? So aluminum is a metal. It only has 3 valence electrons. It's going to give those up. Chlorine is going to take them. So aluminum gives to chlorine. Boop. Perfect. Now, we want to represent that as a Lewis dot diagram. So let's start with aluminum. Aluminum has 3 valence electrons, 1, 2, and 3. Chlorine has 7. So just because you start realizing the pattern of stuff, this will get faster and faster for you. So chlorine only needs 1 more valence electron in order to have an octet. It's going to take 1 from aluminum. Draw an arrow to show that. Now, you ask yourself, okay, but like, is aluminum happy yet? Like, if I cover this up, did we get rid of all of aluminum's valence electrons by doing that? And you should be thinking to yourself, no, it's still got 1, 2 that it needs to get rid of. This chemical formula here gives you a hint that you're going to have to add a few more chlorines to really make this all work. So this guy's happy, but let's add another chlorine. And it's going to look exactly the same, so I'm going to kind of speed draw it. All right, so now we're going to draw another arrow that shows this guy moving. So now this chlorine is happy. It has a full octet. This guy was happy. Aluminum's not happy yet because it still has 1 valence electron that it needs to get rid of. So we're going to draw 1 more chlorine. And again, just because I kind of know how things go, I'm drawing it fast. Now we can transfer that electron there. Everybody's happy all over the place. All right. Aluminum has gotten rid of its valence electrons. Chlorine has taken them up. Everybody's good. So now the last thing is we look at ions. So if aluminum gave up electrons, it is now positively charged. You think to yourself, well, how many electrons did it give up? It gave up 3, so it must be positive 3 as its charge. Chlorine gained some electrons. We're only going to look at 1 chlorine ion, though. The charge on 1 of these chlorine ions, it gained 1 electron, so its charge is just a minus. Okay. Again, we're just looking at one chlorine atom, not all three of them, just one as our ion here. If you have questions on that, you should definitely hit me up or rewind and rewatch. Let's go ahead and move on to another one. Erase this. Okay. The next one should be number 9, which is on slide 8. So we're looking at the formation of an ionic bond between magnesium and fluorine. This time they do not tell you the product that you're making, but we can figure that out relatively easily. So we've got magnesium and fluorine. Our next job is to figure out valence electrons. Magnesium is a group 2 element, so it has 2 valence electrons. Fluorine is a group 17, so it's got 7. All right, who's giving and who's taking? Think about it. You should be thinking already to yourself that magnesium is going to give them up to fluorine, who's going to take them. So magnesium gives to fluorine. Let's draw that out as Lewis dot diagrams. Magnesium has 2 valence electrons. Fluorine has 7. Again, once you start knowing the pattern of these guys, you can kind of, I'm not going to call it cheating because it's not cheating. You're just efficient. So, fluorine just needs 1. Let's go ahead and take 1 from magnesium, transfer that over. This fluorine is now happy. It has an octet. It's good. It's stable. Magnesium is sitting here thinking, I still got 1 valence electron I need to get rid of. What are we going to do about it? Well, let's add another fluorine into the picture. Again, the more you know these elements, the faster this gets. So magnesium can take another valence electron, transfer it to another fluorine. This fluorine is happy. That fluorine's happy. Magnesium has gotten rid of its 2 valence electrons, so it's happy. Everybody happy all over the place. We're good to start thinking about ions. So magnesium, what ion did we form? Magnesium gave up 2 electrons, so it becomes positively charged by 2. So that's a +2. Fluorine, we're only going to look at 1 fluorine atom. Because it gained an electron, it becomes negatively charged by 1, so we just write it as a minus. Hopefully you're feeling pretty good about it. I think I've got one last problem to go over with you guys. It deals with magnesium again, but magnesium with a different atom. It is number 14 on slide 10. So I think this one, maybe I can move it up. I hope so. There we go. So magnesium, and this time we've got oxygen. Oh, you know what? I forgot to talk about the products in the last one. That's all right. Let's move on. Okay, so magnesium, we know is a group 2 element. Oxygen is a group 16, so it has 6 valence electrons. You should be pretty familiar by now, recognizing that magnesium is going to give its electrons, oxygen is going to take them. So magnesium gives to oxygen, and now we want to draw that using Lewis dot diagrams. So let's start with magnesium. 2 valence electrons looks something like that. Now we want to add in oxygen. Oxygen has 6. 1, 2, 3, 4, 5, and 6. So what's nice about this one is magnesium has 2 valence electrons to give up. Oxygen needs 2 valence electrons to give up. So it's a very easy transfer. Magnesium just gives 1 here, gives 1 there. And both elements are happy. They both have octets. They're both stable. If we look at ions, We know magnesium is going to form our cation ion. It becomes positively charged because it's giving away its negative electrons. It becomes +2. Oxygen, because it gains 2 negatively charged electrons, becomes more negative, so it becomes oxygen -2. What I forgot to talk about in the last example was what are the products that are made with a reaction like this. And I'll talk about it with this one. You can go back and fill in the other one. After drawing your Lewis diagrams here, you can write your final product. So we have Mg and, we have magnesium and oxygen, and we only have one of each. So it's very simply just MgO as our final product. I think in the other one, it was with fluorine, right? And it was like Mg, and then it was transferred to fluorine, and then it was transferred to fluorine, right? For that one, you guys, it would be MgF, and because we have 1, 2, there has to be a little 2 down there. All right, so that's just something to be aware of. I don't know that we'll spend too much time on that right now. We're mostly focusing on this and this part, but if you do get a chance to go back and look at those products, that'd be awesome. Sweet. So that's all I have for you guys. If you have any questions at all, if you're wondering about anything, definitely email me. Your next job is to go through and finish the rest of those problems on your own. And if you are stuck on any of them, don't hesitate to email me. Remember, in the afternoon time, we're going to be meeting in small groups and then presenting answers by random selection. So make sure you get them all done. All right. All right. Let me know what you need.